Okay, yes. So today we're talking about developing a custom for our OAIC platform. So starting off, I guess we're just going to some background about Xapp. We've already discussed API model, but we'll talk about I guess it's that. Zoom space for maybe use another. Hello, can you guys hear me better? Much better? All right. Thank you. Okay, so I'll just go in the background of what Xapp is. Oh yeah, do I need to zoom in or anything? I'm going to zoom in the terminal a bit. Oh yeah, sorry. So in the OAIC webpage, there's a new section called in the Xapp deployment. It's not in the OAIC workshop instructions here. It's up here where like the Xapp stuff. There's a developing a custom Xapp in Python, and that's the section that I will be using for going on. So starting from there. So once we can start talking about the Xapp. So we're going to be developing Xapp in Python, deploying it on the RIC, and try and get the Xapp to communicate with the branch. So starting off, Xapp is an application that we deploy to the branch for the near real-time specifically. It's capable of communicating with the branch. And so Xapp, we can do it in any programming language, but to be ORAN compliant, we have to be able to communicate over the E2 interface. And so it has to connect to E2 nodes. And the E2 node is basically something like SRS RAN, or anything that can access the E2 connection from outside the RIC, so the RAN. So for this demonstration, we're going to make an Xapp, but we're going to use an E2-like interface. So instead of using the actual E2 interface that is normally used to connect the RIC and the RAN, we're going to use this E2-like interface to focus on the functionality of the application instead of having to rely on the terminations and rely on the subscription process and the more complicated aspects of E2. We can actually get an Xapp deployed and see the results on SRS RAN. So, and here's the real impact of how the system works. So to understand how the Xapp works, we have to look at how the network is in ORAN. So we have the RAN intelligence controller, the RIC, and it's capable of dynamically controlling this RAN. And it consists of a Kubernetes cluster, and it hosts several deployments. So in this graph here, we see like the diagram shows that we have a Kubernetes cluster that can contain multiple nodes. In the nodes, there are deployments, and the deployments are the different types of applications that you're running. And a deployment can contain a pod, and the pod can contain Docker containers. So the pod is one of the aspects of deployment that hosts the information for this Xapp. And the specific different programs or different Docker containers. A Docker container might mainly run one service. It would function as a microservice essentially. And so the Docker container contains this our code node for the most part. And in most cases, for example, for all the previous Xapps that we were doing, everything should have been in one Docker container. So, and in our case, we're also going to follow that. In our case, for our Xapp, we're going to have a single Kubernetes deployment, a single Kubernetes pod, and a single Docker container. So that will be the structure of our Xapp. As long as we're running one program, that's the bare minimum that we need to get our Xapp running in Kubernetes. So that's how this is. And there's also some more information in the background, and also but it's good to understand this because we'll have the proper working with Xapp, we have to get familiar with all the different commands that we're going to be looking at, all the stuff. So to begin, while you're in the OAIC directory, just check out to a new branch. So there's going to be a new section of code that's specifically for the E2 license, and it also has our Xapp. So the first thing that we need to run is git checkout. would be overridden by merge. I don't see this command, but if you see something that says that that it was able to check out because it didn't write your changes, you can simply just say git stash, and it'll save those changes away, and then you can run this command again. So I can run git stash, it won't do anything, but yes, so you can run the git stash command, and then let me know if anyone else. So first run the git stash command, and then if there's any changes, it'll stash those changes. And essentially, that just means all the work that we did before won't interfere with what we're doing right now. So so git stash, and then we can go back to this git checkout. So in the setup, we copy it, type it in, and what it should do. There's this branch E2 like that doc setup. So it will say that. Check it out successfully. So let me know. Does anyone have any issues? Oh, is it like remove SRS for an E2? Okay, that is, you don't have to worry about it. Yeah, so that is just, it won't do E2 folder. We have a new actually right now, because this is going to take a longer portion of the time, so I want to get out of the way first. So we're going to compile SRS RAM. If we look at our OAIC E2 like doc, there's actually a RIC app ML, and then which is where our Xapp is going to be, and then we also have this SRS brand E2 dev. So if we go here, we can see the steps to compile the E2 like SRS, and we can just follow the steps one by one. So if I go here, first go to SRS brand E2 dev, then I can make the build, so create the build here. And this command has to be run inside this folder. So just run this command quickly after while you're in the E2 dev. And then we can see build, we're doing the same, basically the same. So I will see make it. And while it's making, we're also going to make it, but we don't want to run the same exact command that we did with the E2 version that we ran previously. There's normally you would do sudo make install, but in this case we're going to run the binaries and all the SRS programs directly from the folder. So I would recommend that you don't install this E2 like version, that doesn't mess with any E2. So anyways, when you run this CMake, then you should be able to get all this. So now it's you still have a build folder. So did you go into the SRS run E2 dev directory instead of the SRS run E2? Because it won't. The E2 like version is in a different folder. So no problem. Okay, so while it's compiling, we can start talking about some things about the Xapp. So when we're developing Xapps, in this case, we're just going to use Python, and everything is going to be mostly stored in a single file, because this code is going to be very bare bones. And the concept that I want to be able to show is that we can integrate, in theory, we'd be able to integrate a machine learning model and put it in this Xapp packages and deploy it on the RIP, and be able to first of all, make decisions or being able to, I guess, analyze IQ data that comes from the base station, and then make informed decisions by using predictions. The machine learning model should be able to take the IQ data and turn it into spectrograms. So we're going to convert the IQ data into spectrograms, and they will be processed into the machine learning model. And once we have, I think the diagram shows it here. Yes. Yes. And being able to submit spectrograms, it was possible you could submit spectrograms over the E2-like interface, but we did not implement the spectrogram conversion in SRS-RAN. For simplicity, we're doing it in the Python side. So in this diagram, we have this E2-like agent, which is the implementation of E2 for the RAN. And it goes through the E2-like interface, and we're communicating with SCTP. That is the name of the protocol that E2 uses internally. And we receive messages, and we feed the IQ data that are converted into spectrograms into some machine learning-based classifier. For our purposes in this Xapp, we're not going to use an actual machine learning model, but I can show some example code if it's helpful, if people are interested in seeing what it's like when you actually do implement a model. But for this purpose, we're just going to generate. Yes, yes. Yeah, so, okay. Actually, I'll go into this briefly. So in the SRS-RAN E2, in the E2-like version that we're using, instead of, we are replacing some of the content, we're replacing some of the E2 content with this E2-like handling. And what it means is, instead of writing a service model that we would do in E2, which contains all the implementation on the Xapp side and the base station side, we're using this E2-like interface to create this, like we would say, an E2-like service model. And we're basically that just means that we're deciding how we want the Xapp and the base station to communicate over the SCTP interface. And it's really simple, or we try to make it as simple as possible. On one side, the base station is just sending IQ samples over to the Xapp. The Xapp just asks, in this case, what I do is, the Xapp, we send a message requesting IQ data from SRS-RAN. And then SRS-RAN will send that IQ data back. And then it will process this data on the Xapp side. Then the Xapp will give it a command, which is simply just a letter. I'm just using a single character to represent a specific action that the SRS-RAN can take. So in this case, one thing that we're looking at is changing MCS, or modulation coding scheme. We're using this. I'll elaborate more later, but we went into the code and we modified specific sections so that we're changing the MCS in parts of SRS-RAN. This will be and you will be able to look at this code and see changes that we've made. So it doesn't have, we did not implement KPM or anything in this E2-like code. It just carries IQ data and then it carries commands about it. Yes, so we would have to implement a KPM service model for that, for this EQI. But for this EQI, we're coming up with a different way of connecting the RIC and the RAM in order to control the specific things that we want and to collect the data that we want. So that's what we're doing. So in this case, we're going to do uplink data. We could use downlink as well, but it wouldn't. The SRS, we would be taking the downlink data from SRS RAN itself, and it makes more. It would be. It's more. It's better in a demo to show that we can get the data from the UE side. So for our purposes, we're just going to take the uplink data and see that, okay, from the UE, we can actually see the IQ data. So you would see the combined spectrum, like spectrogram of all these. Oh, sorry. If I do it again, something. So it's just like we're just reading from a buffer that we were taking from a file. Yeah, we see like case M, for example, and we're using if you see the M character in the coming from the RIC to the RAN, then we can enable adaptive MCS. And then we can, otherwise we set fixed MCS. I'll elaborate on that in a second. Once this is compiled, I guess that. So I guess, yeah, what I'm going to do first is talk about the concept of what it looks like when we're looking at the Xapp side. So there is the side that we have to implement here, but the thing that's more important, I feel like, is looking here. It's not too difficult to do in Xapp, but the idea is we have this app.py, and this is, I'll show you. So in the OAIC, if I go to our RIC app ML, there's a few files there. There should be this app.py, Docker file, this init folder, and if you look at init, there's a config.json file. So we have the app.py, Docker file, config file, and then log is just another. It's just a way that I store, like, being able to print debug or like info or warning. And then requirements.txt, which are the libraries that we need for this Xapp. So starting with the app.py, the main portion of the code. So we have this, I have a bunch of initial variables. I have some commands here. So in this case, we're using the MCS commands here. M and Z, I assigned M and Z to these adaptive MCS and disabling the MCS. We also had a version where you could turn on and off, and that adjusts the TX gain of the SRS range. So it's possible to do that on eating mode side. So, and we have some variables to figure out how much data in the spectrogram we're collecting. Then once we're good with that, we have a few things. So we have this init E2, like the entry is the main code that we're doing once we start. We initialize the E2 interface, so it's just an SCTP interface, so it's basically generic code to connect to the IP that's on or like the first IP address of your computer and bind to it. So you start an SCTP connection from inside the RIC. Then we have a loop, so we're receiving connections from other RAN, basically SRS RAN, so other programs. We can receive SCTP connections, and we just do a constant loop while we're connecting. So we have an E2. I just send an E2 like request and I give it a timestamp, and I use this E2 like request to prompt it to send data back from the RIC, or the RAN should send data back over to the RIC, and we just keep receiving chunks of data until we have a full spectrogram or enough data to generate a spectrum. In this case, we're going to, even though I think I wrote 5 milliseconds, but in this case, we're writing 10 milliseconds data, 10 milliseconds worth of data and generating a spectrogram based on that. So then we have a loop, and we're using this time sleep here just so that we don't overload the SRS RAN side, because we could collect and process IQ data really fast. But when we have a machine learning model, it will take slower. It'll be slower because the machine learning model is probably going to be the slowest in the Xapp. But anyways, we use this IQ data, and we can run a prediction. Basically, we can generate and convert the IQ data to a spectrogram, and then we make a prediction with the spectrogram and get the result. And when we return this result, we'd say, in this case, we're going to look at a scenario where there's interference. And we'll have either LTE or 5G data being sent, and our model will be able to detect if it's LTE or 5G or if there's interference present in the signal. And if it detects the interference, then we make a decision to essentially mitigate this interference. So we're using the MCS for this. So it's a feature in SRS RAN that's already there we can leverage, but we modified it a little bit just so that we're able to change it from our E2-like interface. But when we turn MCS off, since MCS is assigned an index, it's a number. So it might hover around, like we have a fixed value MCS of 28 in our case, is what we're going to use in this Xapp. And when adaptive MCS is on, you'll probably see the number to be about 20 to 21. And we'll take a look at that when we're actually running SRS RAN. When we're detecting interference in this code, all we have to do is just send the command over through the E2-like interface. So with that, there's those. And then, so running a prediction, there's just some code here generating using matplotlib is the library I'm using here. And essentially, we're just plotting it and turning the IQ data into spectrogram and then pushing it back so that we can, or returning the fully graphed data so that we can use it in our prediction for the machine learning model. So in our prediction, or for our case in this code, instead of having an actual model, we are using values, and we're just alternating every 8 seconds between having interference and not having interference. And that way, when we actually deploy this and look at it, we'll be able to decide, or we'll be able to see when the MCS changes from adaptive to the fixed value. So this is just an example of something that we'll be able to change on the SRS RAN side from our RIC and our Xapp. So that's just the core of the app itself. And in the meantime, I also I'm going to quickly do the steps to install the SRS RAN. We don't have to do sudo make install, but there is one more command after you make, so just don't forget. We just have to make a few files. So this just creates a few empty files that we need. Although I shouldn't have run it there, sorry. I'm gonna go back. So in the build folder, when you were done with this, then you run those 2 touch commands. Or it's just a touch command to generate 2 files. So I'm gonna save that. So, and now that I'm there, does anyone have any questions about one SRS RAN or Xapp development in terms of what I just talked about, like writing it in Python and how we would implement either in the SRS RAN or the Xapp? If you have any questions that I can try to answer. Can you say that again? Sorry. So for in the SRS RAN side, we're probing the RU to receive the IQ samples, but what we do is we store them in chunks of data internally in the eNode B. And no, we're transmitting them at a slower rate. We transmit them only when the Xapp requests it. And that is usually, I'm doing about every half second or to a second. And we only get 10 milliseconds of data because we're not getting the radio data directly. What we're doing is we're getting the radio data and then we're saving it for later. So when the Xapp asks for it, then we're sending all the samples in a 10 millisecond period, but we're collecting more data than that. Huh? No. In our case, it was closer to about let me check. I'm pretty sure I can check right now, but it's in the order. It should not be that big. It was more of like I can't remember, but it was more like it was less than like 50 megabytes or something, and sending that over was more reasonable. In fact, I think it was way smaller. Yeah, we're only sending a snippet of the data instead of like a whole second, because that would be way too much data.
We are sending 10 milliseconds of data every half a second.
Yeah, so yeah, it's just from the receiving side, yeah. Yeah, you can tweak the amount of data that you receive, but you have to be mindful of what the limitations of your network and processing power can support and how much hard drive space you have, things like that. Yeah, so I think I'll leave it there.
So you're pulling that off 0.
Yes, but so I will yes.
Yeah, we made some changes to collect those IQ within the selection. And throwing that off 0.
It can be 0MQ or SDR. So it has this interface here, this RX now function that's part of SRSRAM. We'll just use whichever radio front end you want. So yeah, no problem.
So that would really just pull off the very best. So it makes sense to make a way to do machine learning in PBR where the IQ sits, where you can highlight. That is like the timing, right? At what time, and that's where the real time may come in. And if you really need every PPI of sub-millisecond, then you have to have it in the D. Or you can't do that with yeah. So but if it is more than 10 milliseconds of the second, that is in the near. If more than that, then 2 hours. So for those who are developing real time, yeah, and that's the current notion. Yeah. So honestly, nobody has done that big better today. And these are some of the questions people are, pondering over right now. Yeah, this guy is right? Yeah. And that makes sense. And when we are going to do it, possibly we're going to do it. Yeah, the capacity, the accuracy, but the support, the compliance of the provider is there.
But I don't. Yeah, can someone look at that? And then, yeah, anyways.
Yeah, let's continue. We don't have to.
Yeah, okay. So once the SRSRAM is built, let's go over here. So I talked a lot about the discussion. So now we can start talking about actually getting I can go here just for a little bit. So we were talking about this MCS. We're affecting the uplink MCS, and essentially we're able to collect these spectrograms and use these to process. So this is an example of what it would look like when we use the matplotlib code and getting 10 milliseconds of IQ data. That's what the output looks like. For my purposes, I won't be able to show it on the screen because I have only a terminal set up here, but you would be able to, technically you could go into Xapp code and save the spectrogram images if you wanted to, if you change the Python code to do that. We would get images like this. So I will start with talking about the deployment finally. So we've talked about the Xapp and the code, but how do we get it on the RIC? So first, we need to build a Docker image like we've done before. Yes.
Even though we are not saying ML model as an example, but we do have some. Can you just go around that just so that people are aware of how you have ML model?
Sure. Yes.
Yeah, even though it's not a part of the table, just see how ML model looks like. Just replace the dummy code that you have now, the random, with that ML model.
Yes, and this code has some parts of E2, so it doesn't. Yeah, so this code was meant for E2 originally. So okay, let me see, because I also have to show, I think, maybe, I don't know if that'll work. Not this one.
So your intent here is to use a deep CNN for determining whether or not there's interference.
Yeah, we use CNN.
Yeah.
That's the poster.
Yeah.
This one? Yeah, that's the poster for this one.
Yeah, over.
And we use CNN with, I believe, 2 or 3 hidden layers. Okay. And then 4 output, whether there is no interference, or if there is an interference, and there is a SOI, signal of interest, CWI. Yeah, CWI or sharp interference or continuous weather interference or no interference. So those are the 3 decisions we make.
Spectrogram, go through a classifier.
Yeah.
Take the output.
Yeah.
So the
Yes.
over there is like when you're using torch, it's like use whatever you want.
Yeah.
Yes, and that code, the example code that I wrote here is based on the radar detection Xapp that we worked on, and it's the posters over there.
But there the intuition was to see whether there exists a radar in the 5G for the figure.
Yes, and so for that implementation, we used a YOLO model, which is an object detection model. You only look once. And in that one, what we essentially, okay, let me see if I can pull it up. So we have this data, we predict the data, and we have an image. It's a NumPy array, but it's basically our spectrogram that was taken from the plot. We can take our model, which this is in PyTorch, and essentially what we're doing is we just shape the model, or we shape the size of the model and everything so that it's good to get the output that we want. And all I'm doing, I'm just calling the model with the image as the input. And what I get in YOLO's case, we get a list of detections. We get a list of bounding boxes. So if you thought of a spectrogram, it gives you little rectangles and tells you there's probably interference in this rectangle, or there's probably 5G in this rectangle, or 4G. So we use those and we collect the most detected and the best confidence out of all of those detections. If we see one where it was really high that there was interference in the section, then we decide that there's interference there. So this is the code that is relevant for like predicting data in PyTorch. That's the PyTorch section. For this section, this was the section of YOLO. So we look at all of the predictions that we got from the model, and we essentially find out of all the confidences, which confidence was the highest, and specifically which identifier, so 5G, LTE, or interference, which of those had the highest confidence value. And then if we do that, and the score, if we have a confidence value that was high enough, we just did like 0.1 in this case, then I output that, and we're able to just count this information, and eventually we get the average of all the confidence values. And we can use that we use some code like this, and essentially as a result, when we do this, we will get LTE 5G or interference, and then we can make a decision. If there's interference, then we just send that command to turn. In our case, we control the TX gain, so we actually use those base station on and off commands if I have it. But yeah.
Would be made available the second release, like I said earlier. So you should be able to have the code, maintain it, whatever you want to do that. Yeah. Okay, let's get back to the game.
Yeah. So yeah, the first step that I want to talk about, and now I need to make this larger. So first is building the Docker image. This is what the Docker file looks like that we're going to be using. And I'm going to switch back. I have 2 different windows open, by the way. I have one for the E2 dev build, and I'm going to go over to this Rick app ML, which is in the OAIC folder. So once we're in that folder, there's this Docker image, and what we're doing is we're just loading from Miniconda, which basically is just a Python setup that has some of the stuff that we need for machine learning. We can install all the libraries that we need besides Miniconda, so it's just a few things. And this is based on Ubuntu, so we're just using Ubuntu commands, and it runs the same way. Just apt-get update, apt-get install. Then we just copy all of the files that are in this ML directory. So if I take a look, and I accidentally made these bin files, but everything in here that you see will get copied over to the Docker image in this temp ML folder that we decided. So then we decide that temp ML is going to be the folder where our Xapp is hosted, and everything, that's our current working directory. The moment we start this Docker image and we deploy it, because we didn't specify anywhere else, this is the directory where it will be running in. So then we can do pip install based on the requirements txt. I'll take a look at the txt, and we just have matplotlib numpy pillow, so it's just some basic things. And then we can set our Xapp to run immediately when deployed. I mean, what that means is that you have this command and it runs app.py. I think I changed it. Let me make sure I changed it. But yeah, so I make it run Python 3 and then just the name of the program. So that's the command that will run immediately once this Docker image starts. So that's fortunately not too complicated of a Docker image, but that's the kind of structure that you would at least expect to see. So once we have it, we can just build it and submit it to the registry. So we can use the same registry that we were using for the previous Xapps. And we just have to run this command in the Rick app ML folder. So make sure you're in that folder, and I will paste that command. And
so remember, right now we are at some early stage where we make -j and
oh yes, okay,
right?
yeah. So I
see that in mine it is completed. So
yes. Okay. So in a separate, yeah, let me be more clear about that. Sorry. So once we've done the E2 dev build steps, you can go back if you want to use the same window. You can go back to the OAIC directory, or you can just do cd ... to get back there, or cd ... / like this.
So you want us to
go back to the
remaining steps, because we just did make -j.
So yeah, well, oh yes, complete the remaining steps. Yes. Sorry, sorry if that was not clear. So do complete the touch agent bin and the IQ data last full if yours finished compiling right now, and then run those last two commands, and that would take you back to the OAIC directory. And we can just do so if you've already got 0MQ running, you do not need to run these commands. If you've got any of the Xapps or any of the UIs to attach prior, you should not need to run this command. But even if you didn't, you would have had an error if this command didn't show up. So, but just in case, I'm going to show what it would look like. There's these two commands here after the touch and the CD.
So we run not run what?
So yeah, so I would suggest running it just to make sure, at least one of them. So sudo nano root config srsran. We're going to the enode b config. When we look, yes.
We commented out something. So
yes, so this is a different one. And just because it was different on some people's, it was different on mine for sure. We want to go down to this RF configuration section, and you'll see this brackets RF, and eventually you get to this point where it says example for ZMQ based operation, and there's this device name and device args. If it looks like this, because for some people it might look like this is commented out, I need you to uncomment it so it looks like this. And the UE config also has the same thing. So if you need to do this, then you also need to do it on UE. But is there anyone that has any questions about that?
So So what line number approximately so that we
Let me see. Oh, I'm not in Vim right now. Hold on. I can,
okay, device basically you need to look for device.
or yeah, it's in the RF. When you see the RF graphic here, I think it's probably about 60 lines, 70 lines down at least.
Yeah, currently it is commented out, I think, because
Okay, then I would, yes, please
Uncomment, yeah?
uncomment it. Yes.
oh, uncommented.
Yes, and those will be the, yeah, because it'll set it so that we use 0MQ with a single UE, the same configuration that we want to use at the beginning. So, I will, yeah, I'll leave it up for a little bit and make sure that everyone gets to that.
And how do I get out of this? Because I'm
Oh, you can,
trying to
so
set
you can use Vim also, but if for Nano, you can do Control X.
Control X.
Yes.
You will save it.
So if you do Control X, it'll say save modified buffer
yeah, yeah.
here in this section. Yeah, on the bottom, and then you click Y, and then you click Enter. Sorry if you guys are using Vim. So yeah, heads up.
No, we
Yeah.
just type this
Yes.
copy paste.
Yes.
So after that, to exit, what do we do?
So you did save it.
Yes. Save Y, and after we save, then you still in.
Oh yeah, and then you have to hit Enter. Make sure to confirm the file name. So it says like file names are right. If you select Enter, then it will close. So Control X, Y, then Enter. You do, if you want to use Vim, that is fine. So Nano is just another text editor in the terminal. We were using Vim before, so if you want to replace any instance of Nano with Vim, you can. Yeah, and then I will also just confirm that in the UE section that there's this RF configuration also. So if you need to change that, and just go down so we can see it. There also is the same section in RF. Yeah.
Device name.
Yes. So if you do need to change that,
Yeah, here it is
That's
not
good.
comment.
okay, it's not commented. Okay, then
Right.
sorry. Then yes, and you can do Control X. Yeah, and it'll close if you didn't make any changes. So, oh, did it not? Did it stop sharing? Sorry. I think it, yeah, it did stop. Okay. Okay, back. All right, is everyone done with that step, or does anyone? Good. Okay, I think everyone's good. So, this is the next step. Once we've built once we're running the command, we need to go from OAIC to RIC-app-ML. So, if we look at OAIC, we can cd into RIC-app-ML, and they'll take us here. And yeah, once we're at RIC-app-ML, then we can run the sudo docker build command, and it'll build the image that we have up here. So, or in our Docker file. So I'm going to run sudo docker build. I've run it, so it already runs faster, but yours will take a little longer. It shouldn't take as long as the previous ones though, but it does have to install NumPy and a few things. So I will start for that. And so you can also see, well, this command also shows the same things here. It'll build a Docker image called RIC-app-ML. If we look at this command, this is the Xapp registry that we're using with the port 5008, and we're tagging it with the name of the Docker image, which is RIC-app-ML, and then we have a version number that we can associate, which is 1.0.0 in our case. But this version 1.0.0 has to match the stuff that we do later, so that's just something to keep note of. And I'm assuming, well, yeah, so it'll take some time for people, but also I'm going to show this while it's running. So you don't have to create this config because I already put it there in the init folder, but this is what we have to create a config file for this Xapp. And we can just take a look at what this example one looks like. So we have our name, the RIC-app-ML is the name that we're calling this Xapp. So the JSON URL and the Xapp name and everything align with it. We have the Docker image and the containers. So we have this RIC-app-ML at this Xapp registry. the name of the image, and version 1.0.0, which is the same thing that we put in the sudo docker build command that lines up with this. So these have to match what's in the docker build command.
So whatever Xap name you want to give,
Yes,
that
yes,
will be like rig-app-ml.
yes,
And then 1.0.0 is the version of that Xap.
yes. So that needs to you need to make sure in the config file that that's the same thing when you're developing a new Xap. In this case, I already did the work. So we have the containers. So this is a Docker section, but we also have some ports, and these are the network section. So what ports are we using, and do we need to talk to from outside the container itself and outside the pod? So for this Xap, although we're not using them for an E2 interface, you would have this RMR data, which RMR stands for the RIC message router, and that's how we handle E2 information generally. And so there's a route port and a data port. So those are the names of the two ports, and we see there's like a list of types of messages that we can send, like failure indication, subscription response request. Those are just the types of messages that we would see in the RIC, and we just need to explicitly specify them sometimes. So those are the ports, and that's what it would do, is it would open up E2 like, or not, this is not E2 like, but E2 ports. So in the E2 like, we're going to actually manually add a port later, and I'll show you how to do that.
These are default. We cannot add or remove, right? This is what we have.
So you could technically delete these, but these are the E2 ports. So I just recommend that you keep them, especially if you're going to use E2 in the future. But
for messages, you have
these messages, yes.
So they have to be only these, or
so you can, if you know there's other messages that you need to send, then you can add them. But in this case, we're only looking at, these are the messages that were preset, and these are based on KPI mon. So these are actually the types of messages you would see with KPI mon, or the specific messages that KPI mon sends and receives. And these are on the E2 application protocol level. So these are not based on the service model. So it's not based on like sending a KPM or anything. This is just based on like being able to initialize an E2 connection or being able to receive indication messages. Those are high level, or like those are more abstract E2 message types. So, but in this case we're just going to talk about E2 like. So
also because it's an indication for security. So what kind of messages can be accepted for a particular example as well? When attacker is attacking some other type of message, say control message, it's not enough. You get to know something.
Yes. Yes, and when you implement an Xap with the E2, it's important that you have to be able to handle every message, or otherwise your E2 wouldn't function correctly in your Xap. Or at least be able to detect if there's a message that you don't expect and just not handle it intentionally. So once we're done with that, I'm going to make sure. So is anyone still doing the Docker build, or is everyone done with that? You're still running? Okay. What step are you on? Are you on the step 5? Okay. I'm going to continue on a little more. If you want, you don't actually have to, you can open another window if you just want to let it run. Like, yeah, it's no problem. So for the next step, so step 3, I'm just gonna, I did number these steps for the deployment. We need to find the IP address of our computer, and we need to save it in this variable because we'll use it later in some other commands. So you just have to run hostname I, and you get an IP like this. In my case, I have 192.168.122.20, and then we have to run the next command. But you have to replace IP address, the one in brackets, with your IP. So in my case, it would look like this: export host IP equals 192.168, and then the rest of it. So
but there are multiple.
So you choose the leftmost one. Yes. Yes, you can use the first one, and that will function. So, and no one has any issues with that. I think. Yeah. So then finally, so we already did configure the web server. So we actually do not need to run these steps unless you haven't run them before. But in my case, I'm just going to go through them quickly. So install Nginx if you haven't already, but if you did deploy an Xapp at least once, then you've already done these steps. So you also have to create some directories here. These commands shouldn't take too long to run. You have to go in this
I'm
Xapp.
sorry,
Yes.
but are we supposed to do it or not?
If you have done,
apt install ng, I don't know what that is.
so you do not have to run these steps if you deployed KPI-mon already in the previous
We got stuck.
in the previous session. So, or well, no, sorry. If you attempted to deploy
We attempted,
KPI-mon,
yes.
if you attempted to deploy KPI-mon and you at least I guess I can look at the specific step that you would have had to get to, but this was like the first thing before you could even look at before even getting the SRS ran to run or anything. So
There's no harm in running.
yeah, there is no harm in running.
No harm. No,
There is no harm, so feel free to run. Yes.
There is no harm.
So I'll just do them quickly. I'll just speed through it. Does anyone have any questions? So if your Xapp failed, it's okay, because we're actually also part of the issue with KPI-mon is some of the E2 pods have issues, but because we're using E2-like, we can ignore those. So I'm running the commands. It says that web server Nginx is running. Then I can create these directories. It'll say that they're already created because you've already run it before. Then it'll just say cannot create directory. So there's no harm in running these commands, but you might see errors, but they're not real errors, I guess. So because if you've already done this, so I went into this local Xapp config local conf. You should have this content in the file, which is below here. And then you can save it. You can use nano or vim for this. And once you've changed the config file, then you can run the sudo nginx t. And if I run this command, it'll just say that the config file, it reloads the config file, and if you did it correctly, it will say this. It'll say test successful. So
we have to open that config file basically and copy paste.
Yes. If you go in there and you already see it there, you don't have to do it again. But if it's empty when you open the file, then you do have to copy it. Yes. And nano, I use nano because you can right click with the mouse and paste it directly in. So that's, yeah, you can use the mouse to quick paste. You can click paste on the mouse and it'll work. Yeah. And then once the config testing is successful, then that completes step 4, and you have the web server for the config files.
If it is completely empty, my file is empty.
Okay, so then you do need to run this step. So you just.
I ran the step.
Oh. Which one is empty? Sorry.
Yes, it's config file. I did the sudo nano.
Yes, it is empty. You said.
It is empty.
So yes, you have to go in there and copy it. Yes. So if I did it, I would just copy it, Control C, and then I can right click, paste, and it's there. And I won't save it but yeah, anyways. So you would, once you do, or for nano, you can exit with Control X, and then you select Y, and then enter. Once we're done with that, then you can run this command sudo nginx t, and what will happen is it'll reload the config. If you typed everything right, then it'll just say it's successful. Is it good? Okay. Is there anyone else that needs to do this, or can I continue? Okay. All right. So step 5. So we're going to use our config files for this Xapp. So everyone has to do this step now. So first we're just copying the config file from our init folder. So you should be in the Rick app ML folder right now still. So this is where we were before. It shouldn't have changed, but then you can copy this command to take the JSON file and move it over to the web server where all the config files are stored. So I'll run that command. Then the next command is this. This happens in case this is just a fix in case you don't have access to the file or the Xapp onboarder. When we deploy the Xapp, we might not have access. So we're just going to quickly take that and make sure that it has read and write access, and execute access. So do run that command in case there's any problems. Then if you already had, oh yes. The first one, this one. Are you in the Rick app ML directory? So if you look at like ls init, do you see this config JSON file here?
So did you follow all the previous steps?
So make sure. Well, yeah. So the previous steps, you just have to make sure the config file is actually here. It should have been here. As long as if you already did the E2 dev and you built that and you have this Rick app ML folder, you should, in the Rick app ML folder, in the init folder inside, there is a config.json file.
Did you do Docker build?
Yes. You did. No, we see the config JSON.
Oh, okay. So then you can run that command to do the copy, and you should just not output anything. And then you also want to do the chmod. Once it's copied, we're just changing the permissions of the file after it's been copied. So that's what we're doing. And in case you don't, yeah, I would recommend just restarting Nginx in case there's any issues with it. Especially if you're on a new setup, sometimes the command or the config files don't immediately take action. So we just restart it. It doesn't hurt anything. So yeah. And then we restart it, and then the final thing that we do in the step, I think, is we can check if our config file is in the right spot, because if you copy this command and you paste it, you should be able to get the config file, and you should just see all the text go out. So that means we just downloaded the config file from the web server. Then that means you've succeeded there. So once we've done the curl there, I guess I'll wait for a little bit. So, all right, is anyone else still doing this besides one? All right, I'm gonna continue on the next step. So step 6 is creating the onboard URL file. So it's the same way as the other Xapps. So we make sure that we have this IP address, because we're going to need to copy it into the file that we're about to create. We're creating an ml onboard.url file. So I echo out the IP, and I'm going to just copy it for my purposes, or you just remember the number. But yeah, I would copy it. Then you can go into this nano or we'll be creating a file. So we do nano ml onboard.url or vim, and I'll open it. It's empty. We just have to first. Oh, actually, there's 2 problems. I thought about it. Okay, so you do actually have to remember the IP address that you came up with, or put it in another window. So in my case, yeah, sorry, I put in. Yeah, I should have written it differently. If I'll put it in a different window, because we have to copy something else. So in this case, here, let me just do this. So we have to copy this in the file that we have. So once we've copied it, there's this machine IP ADDR address section. And in here, we just need to input our IP address. So I think in my case, it was 192.168, and I'll just check. You can use hostname I to get it again in case, or you can use echo host IP, whichever one. That'll give you the address. So it's the 122.20 for me. So I can just type it in there in that section, and then I can save it. So, and I'll leave it up for a second actually. Sure. So yeah, once you have your IP address, then that's the last step before we start actually deploying the Xapp. Does anyone have any questions about that? Or is everyone done?
Can
Yes.
we wait,
Yes, I'll wait a little bit.
So the only thing we type is the IP address. Is that right?
Yes, they're in this section. So it has a config JSON URL like this, and then
No, I'm talking about the previous.
so in ml onboard.url.
Yeah, it is empty. So what should I
So you copy this. Sorry,
copy that?
copy this, and then there's a space called machine IP address,
Okay.
and then sorry, yeah.
Yeah,
I wrote
know.
the thing in the wrong section, so that was my bad. But yeah. But yes, so and you can find it. It says it in the documents. How yeah. And going up, sorry. If you need to see this. And is anyone still on this site? Okay. I'm going to think I can or yeah, are you ready? Okay. I'll progress. So before I get to the next step, which is step 7, where we're actually going to start deploying the Xapp, I'm just going to talk a little bit about the RIC for a second. So we have these pods, and there's one thing that we're going to be using is the Kong proxy. And this is basically first we're collecting and storing the IP address of the Kong proxy to a variable. What this is the Kong proxy is basically just a way for us to access the different components of the RIC through one IP address or one web interface. It has all the APIs of different sections. So there's things like the app manager and the Xapp onboarder. Those are the two main ones that we rely on. To Xapp onboarder allows us to store our Xapps in the RIC and how to create them, and then the app manager actually executes and deploys those Xapps on the Kubernetes cluster. It'll generate all the pods and everything. But the Xapp onboarder is the first thing we need, because that will give us that'll take our config file and it'll turn it into the instructions to deploy our Xapp. And we call that a chart, or yeah, an Xapp chart. So
Is that the same as the Helm chart?
yeah, it's similar to a Helm chart. It's related to the Helm chart. So we can actually just run this step. I'm going to go back to where we are in the RIC app ML, and we just need to export this Kong proxy variable. So just copy it and paste it. And if everything goes right, you don't see anything. And then the first step that we have to do, we're actually going to submit using this onboard URL file. The purpose of the onboard URL file is it's a JSON file that contains the URL of the config file so that the Xapp onboarder can download it and handle the information that way. So all we have to do is just run this command next, and it'll, as long as we're in the Rick app ML folder, it'll take the ML onboard URL file and submit it over to the Xapp onboarder. If you do it, it should say created by the end of it, and yes. So, and I didn't put it here, but there's another command you can access to look at the charts. But the concept is that we have our Rick app ML, and it's in the Xapp onboarder as one of the charts now. So finally, after this command, once we're good, we can use the app manager and request that it deploys our specific Xapp. So we look at this command. We submit a JSON, some text that says Xapp name and then Rick app ML. So that's the name of our Xapp. You could also replace it with SCP Rick KPImon for the KPImon app and other things like that. But that's the way we start an Xapp. And what we're sending a post request. We're basically just using the APIs of the Xapp onboarder here and the app manager over there to be able to fulfill everything, and it's all HTTP GET POST requests. So once I run this command, then it'll wait a second to deploy, and then I'll get it to deploy. Then we get this status deployed. This is the important part. So name recap, yeah. So version 1.0.0.
Yeah, can you tell us how we can verify? I do not see any response.
Yeah, it takes a while to. Oh, do you like? Did it complete and is it respond?
Yes.
Oh.
Even for export, there is no response. It's called very good.
Oh, sorry. There's actually two commands here. So first, there's a first command here that submits this Xapp config file. So they look the same at the beginning, but they're actually different. There's one here and here. So make sure that you run the first one, which is onboard. And when you do that, then it'll say created, status created. And it might take a second, but yes.
Oh, created, yeah.
Oh, it's empty. I'm gonna redirect you to a step. Sorry. When we create the onboard URL file, we want to have this information in it. So you copy this in the ML onboard URL, and then replace that machine IP address with your IP address. Oh yeah.
Yeah,
It's no worry. Yeah. So
whatever you said, I followed now.
it works now.
Deploy.
Okay. Does anyone else having issues with it, or did it deploy? Okay. All right, then I will look at the next one. So yeah, once it says deployed, we can actually just use the command here, sudo kubectl get pods a. If you want to confirm for sure that your Xapp Rick app ML is now running, and it's in the Rick Xapp namespace, so it's in a different namespace from the other infrastructure of the Rick. So some information about the Xapp. Once it's deployed, it'll automatically restart itself on failure. It'll continue to run even if you restart the computer. Same with the rest of the Rick, and as long as the Kubernetes cluster is running anyways. So you have to manually restart an Xapp when you make changes. And you also have to rebuild the Docker image and do some other things if you need to change any code. But you have to manually restart Xapps, and you also have to manually undeploy an Xapp if you want to stop running on the Rick. So one tip, if you have okay, maybe I'll do this right now. I'm going to.
So right now he deployed it. And
Yes.
it's already running.
So yes, it is running.
Then we can see some spec program kind
So I won't be able to show you the spectrogram, but I can show you that it's receiving the spectrograms and other information once we're going to start SRS-RAN very soon. I'm going to refer to one thing before I get there. Let me make sure it's here. Okay. So what I would suggest, if you, well, actually, I'm not going to do it yet, but if you have problems, I'm going to explain later how to undeploy KPImon, because if you have KPImon running for too long, it can cause issues. So in this case, it's not affecting the E2. So as long as you have more than, if you have at least 8 gigabytes of RAM, it should be okay. But I'm going to investigate. So here are some, assuming that you've got RICAP ML deployed, we can look at some of the commands. There's some commands to view the pods, the services, build your Docker image, restart an Xapp. So you might need to restart the Xapp if you have any troubles. So you can use that command right there. And you can restart any of the pods with the same process by just replacing the name here, and also making sure that the namespace, which is ric Xapp, is matches. If you need to restart any of the other pods, then you have to do ric plt if it says ric plt on the left of it. We can also view Xapp logs, so I'll do that right now. So we do logs n ric Xapp and then the pod name. So I would copy this and I can paste it. In our code, we see E2-like enabled, connecting using SCTP, and the server started. So you can also do that if you would like. And there's some other commands that, for convenience. For example, if you want to debug your Xapp, or if you have any problems, you can open a terminal or a shell inside of your Xapp's pod. So this command, if you replace the pod name here, will open up a terminal, and you can access all the files in it and do whatever you need to do. So that is one thing. And then you can also, this I will talk about later, because we're going to have to run this command in the SRS-RAN step. So does anyone have any questions before I continue? Okay. Then we'll get to connecting the SRS-RAN. So we're going to use a modified, we're using the E2-like interface, modified SRS-RAN. So to connect our Xapp E2-like interface, we're going to use port 5000 for our RIC app, or basically our Xapp. So in Kubernetes, we can open up additional ports, network ports, as we want to. Although we can also do it in the config file, but in this case, I'm going to open the E2-like up in the command line with this command. So essentially, we're enabling SCTP connections on our IP address by creating a node port service in Kubernetes. So I'll show you when I run this command, it will say service ric Xapp ric app ml exposed. Then I can go to I can do this command, which is in step 2. And when I run this command and I exposed it, I run services. Then, and I'll make it more visible. We have the service ric Xapp ric app ml RMR, which is the port 560. But we also have this ric Xapp ric app ml, and this is our node port. We're basically redirecting one of the parts of the traffic that go to port 5000 on the Xapp, and it comes out on a different port, not 5000, but it's on our IP, our internal IP. So now we can access it from outside the RIC. And so we need to find this IP address, or sorry, this port. 32015 is the name of my port that it got exposed to. And it will be different for you guys. So just, it will most likely be different. So when you run this command, just look for this port and keep note of it. I'm going to, in step 3, change, or we can store it in a variable using this command here. So I'm going to use export. Oh, sorry, I closed it. So 32015 for me. Export Xapp port equals 32015 in my case. So that's step 3. We're going to use the Xapp port when we start all the SRS-RAN instances up. So that will be that. So we'll set it up that way. And you might need to do, if you open up new terminals, because we're going to do this for SRS-RAN, you may need to run that command again. the command, it needs to be run before you run the base station, but I'll get into that. So I'm exporting this Xapp port. I can confirm that if I run this command, yeah. So I get 3215. Let's see. Does anyone have any questions about this section? Okay. Then finally, we're going to start everything up. So assuming you have the E2-like version of SRSRAN, go to where SRSRAN, the E2 dev folder is in the build folder. So that's where we stored our SRSRAN. So if you have OAIC in the directory, go to OAIC. If you have it somewhere else, just go to where OAIC is, and then you can go into the E2 dev folder and then build. So I can run this command, build, and I'm here. And then you want to run the next, all of the terminals in this directory. So in my case, I'm already going to be there because I'm the way that this, oh, well, actually here. So I'm going to start a few more windows. I think you need, let's see. You need one for EPC, one for eNode B, one for UE, and then we'll need some for iPerf. So that would be 5 windows at least, but I recommend 6 windows so that we can look at the, we're going to look at the Xapp logs. We're going to be able to start the core, start the base station, then the UE, and then we're going to send traffic, uplink traffic over. And then we'll be able to look at the UE and see how the MCS changes. So starting off, make sure that we're in this folder for the next commands. If you have to run Xapp port, well, I'll say it in a second, but for EPC, you're okay. You just have to be in this folder and run in sudo srs EPC source srs EPC.
So right now we are working in a folder.
Yes, in this srs and E2 dev build.
Yeah, so we did all the steps. So you want us to open a new terminal for the EPC and so on?
Yes, so yes, first start the EPC in a new terminal if you haven't already. If you were already running it from your previous session, that's okay. So then we can run sudo srs EPC here. And then for the base station, make sure that you do have the IP. If you don't have it, yeah, you might need to write it down again. So in this case, I'm going to use.
It says already use an error billing. So whatever I have.
Already in use? Oh.
Yeah, because
okay, so yes, I'm going to write that here.
Okay.
No, it's not.
Not
but I have a solution. But you have to do it for. So in this is command here, sudo pkill. You can use like -5 is what I use, but if you type this command in, it will close any EPC that's already running. So if you have port in use, that means that there's another EPC already started. And you also probably sometimes when the eNode B crashes, this can also happen. So you can also replace it if the eNode B happens to be running and you can't get the port, then run kill enb. Yes.
It seems like that whole assistance team, they have tons of debugging experience from doing this. So one suggestion, how about adding to the documentation section just like a base experience? It's like Q&A.
Yes, I agree.
Like adding it in Q&A format. Yeah. Like when this happens.
Yes.
When this happens.
And in this demonstration, I did start writing more of this information. Like we might see like the SRS ENB won't connect to the Xapp. If it crashes after a while, I've been starting writing some information, and it'd be a great idea for yes.
Each one of you have even more than one solution for the same problem. So it's like if you can kind of like aggregate this experience, this will save the user.
Yes.
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 And it will change that usability of the program.
Yes. Yeah. Thank you for that input.
Yeah, good.
Yes. So and yeah, we need to aggregate in the configs or like in the website. That's a good idea. So we have, assuming that you can start EPC, I'll go back. So I have EPC here, and then next I'm going to start the base station. But before I do that, I have to make sure that this host IP, I have to do export host IP like this in here, and then replace the IP address with the IP address that is on your system. So
Right now I'm here in build, so does it matter?
it took me to OAIC. Sorry. Yes, you should be in build. I didn't notice that. Yes, should be here. So yes, thank you for that. So run export host IP, and if you need the IP address, then do hostname I to find it again, and then run that. Export host IP. I'm gonna also. So yeah, give me 1 second because I need to also do this in the other. So SRS for E2 dev build, we're gonna start the base station now. As long as the Xapp should be running by the time, like with the E2, it can take a long time for the Xapp to run, but since we're on E2, like it starts instantly, so you can just run the enode B here. There's some commands here you can see. Oh, actually, before I do that, I need to be clear. There's one other command, which was step 3, and I need to make sure that you run this, or if not, I would run it again in case. You need so previously we did the, sorry.
I think we already did that, right? We followed the
Yes,
steps.
yes. So
We
you just
already
might,
did
yeah. You may need to do it again if you have an error, but if you don't, just keep note of this IP address, and because you'll need to put it in the Xapp port. Yeah, sorry, the port. Yes. Keep the port, and I'm going to. In my case, when I open up a new window, it doesn't save the variables anymore, so I have to put in this one for the enode B. So once we've done that, and we have our host IP and Xapp port and variables, or you remember them, if you want to type them in manually, it's step 7 that we're going to be on. Step 3 is where the Xapp port is, if you got lost on that. But step 7, I can paste the base station. We can see that I have the Xapp port as the remote port, and the IP is the remote IP. Local IP can be host also, and we just use this port 38071. It can be any free port on your computer, but that one will work. So then also for the scheduler, I set a fixed MCS value of 28, and it's going to change when the Xapp signals the enode B to do so. So if I run this, then I will be able to open it up, and I will see that it's connected. In this case, I see this E2 established received E2 like request and wrote this command. So we're
the same problem with this. So I do sudo pk -5.
yes. If you step 5. Run it in the here. I'll show you again. So it's in OAIC SRS run E2 dev build folder. All of these the following commands from here on out should be run in there. Yeah. And sometimes, let me see if this happens. It's not as consistent in this case. And I'm actually going to let you know. So this output, ideally what should happen is once the Xapp receives a connection on the base station and they start talking to each other, they should constantly go back and forth. In this case, it failed. So the connection got lost in some regard. So in my case, I'm going to restart the Xapp. And wait just a little bit. And in the meantime, I'm going to talk about for a second. So basically what the Xapp output would look like on the RAN side, once it's connected on the E2-like interface, they're just trading IQ data and commands back and forth. So you'll see IQ data sent, and then you'll see command received from the RIC or from the Xapp, and it'll keep going back and forth. And once you connect the UE, then you'll actually be able, or then the MCS will start being adjusted. So you won't be able to see, the MCS changes won't actually occur until there's an established connection, because the MCS only is available once once a UE connection is established and it starts scheduling on the UE. So I'm going to run the enode B again, and if it connects, then we're good. So now we see these constant send IQ buffer, wrote E2 like message. This is the type of output we're expecting to see. So
It is okay if we failed to send some 16,000.
so if you see that, I would close it, because yeah, that's not actually what it should happen. You need to close it, and then or control C, like just close the stop the enode B, and on the this is managing Xapp deployments section, which is higher up. This is restart Xapp command that you need to run. So do that, and then you can wait. I would wait 30 seconds or so, and then I would try the enode B again, and then you should start seeing a constant flow like this. Oh, it is? Okay. Let me see. Okay, so you said the bin file? Oh, you're saying where, so you've compiled it and everything and you're just running sudo, okay. Did you run the touch command in the original step? Like, so once we did make jnproc, after it there's a touch, like touch agent command, and then check it out and make sure that those files exist, because if they don't, it causes the program to crash currently. So, but once it's there, then it should just be smooth like this. They do exist. Can you just run the command one more time to confirm? Yes. Yeah, I'd see if it might be a memory issue, but so sometimes, yeah. In my case, yeah, so I'm able to get it to function. So the next step is go in another window, and we're going to connect the UE. So UE, make sure that the UE1 network namespace exists. It should be in a previous command, but you can also just run the command. If you haven't done it before, you'll see nothing. If you see this cannot create namespace file, it exists, that means you already have it. So you can continue to the next step. Then step 9, you can start the UE. So I'm going to create 2 terminal windows before I start the UE, and I suggest you do as well, because one behavior of SRS RAN is that when you connect, or I mean once you connect the LTE connection, if there's not any traffic happening fast enough, then it will disconnect the UE from the core. So just do not try to do the next steps faster. I'll just actually say the steps now, so before I run everything. So I'm going to start the UE, and then I'm also going to start iperf in another window and create an iperf server from the UE side. And then we also have to find the UE IP address, which once we connect the UE, we're going to get a message. It's going to look like this. It'll say network attached successful, and we get an IP address. So we want to use this in this step 9 here. We have this IP address, and we want to use that in step 11.
Should we execute number 9?
So we can, yes, let's execute step number 9. So sudo UE1 and see if we can attach. It found it, random access complete. In my case, it did not connect for some reason. Oh, because SRS ran crashed. Okay. That would be a reason. I'm going to stop it, and I'm going to start enode B again, see if it connects. In this case, it didn't. Okay, it didn't initiate an E2 like. I'm going to restart the Xapp here, and with this kubectl rollout command in case, and then I'm going to start the base station and then the UE. When the UE, if the UE attaches successfully and the base station connects, then we can run the iperf commands, and then they'll start sending traffic back and forth. Just make sure to remember to replace on step 11 the UE IP address with the one that you find when a network attach works. So I'm going to start it now, and it's connecting. I'm going to start the UE, and for some reason I'm not getting it to attach, but let me see. So random access. If it crashes, then you can restart it. It's not a problem. Okay, I know the problem for me. I didn't, hold on, sorry. Wait, no, I don't. Okay. I see, so there's a base station. There's the, and the node B. Okay, so I see actually what's happening. The moment the UE is connecting, let's see. So we're able to send and receive IQ messages. It's just that at some points, let me make sure. Oh, I don't. Okay, so we are filling out the IQ data. Were you able to get an IP address? If you do not, if you don't see it, then
Yes, I have to.
I might also be experiencing the same thing here. Because for some reason, I'm going to connect it again. So I'm having, okay, I actually am having an issue on the UE. I might have to, I think I'm having an issue this time. So, I'm going to do a test there. The issues when the that's the but I'm also doing the test with my dev. So when I tried, yes, but I did have to go. See. I have to wait for it to close. Once they use their random access, and then for some reason it's crashes. So that's weird. I'm gonna do. What's it? Yeah, sure. No, this is the last section. It's just like, so it's.
Whatever that may be. And then by then you'll also have the opportunity to work on your own on laptop and follow all those locations. Right. So I would say let's stop here with the hands-on session. And then let us go to the networking session where we go through all the posters, we talk, and then again, I guess we come back tomorrow. Joe, is there anything else you want to say for today? Oh yes, please do vote. Okay, we definitely need significant number of votes to make a decision. Right? It's just one vote that it doesn't make sense. Each one of them, go to the posters, talk to the presenters, right? And this vote. And it's publicly available on the website. So just go in that part.
I don't really have much more to add. Thank you to those online who have been very diligent working through the tutorials and hands-on sessions as much as possible. We will pick up tomorrow morning at 8:30. Same bat room, same bat channel. And for those of you who are here, I guess, yeah, take advantage of talking with the other students and professors, faculty, etc., looking at the posters, and yeah, enjoy Blacksburg for as much as it has to offer. Thank you very much.
Okay, so let's give a round of applause for the undergraduate students. So yeah, feel free to talk to him and know him. Okay, so that's all for today. Thank you all. Okay, so guys, the one who are presenting, please be by your posters and then the rest of you.
Let me share the screen. Okay, so I'm going to continue off from where I started with the Xapp, but since we were having some issues last time, I won't be able to guide you through this process since I had to make some fixes, and I'll make the changes later, but I do want to show you guys a few of the things that I had to do to fix it. And I ran into this issue, but I hadn't ran into it on the virtual machine I was using until we ran into it yesterday. So one of the things that was significant was that the way that we're saving IQ data and the way that we're processing commands. SRSRAN is a multi-threaded program, and there's different sections of the program that handles things such as the E2, receiving E2 messages, handling the TX and RX messages, doing things like UE scheduling. Those types of things are split into different threads. And so since they run concurrently, sharing variables is a bit difficult. So the simplest thing that I did for using SRSRAN, I just wrote things to the hard drive. I would write the IQ data to the hard drive, and then they would get it and then send it over E2. I did that with the commands as well. Anytime an E2I command was received on SRSRAN, I would also I would load a bin file. So maybe I can find it, but I mean, this is the idea. I would just be opening a file. So the problem that we were experiencing last time, there were a few errors with since the version on GitHub was missing a few things, but the main thing is that that the hard drive is sometimes too slow to handle this connection. So even when I did get it working, it was unstable. And the reason being is when you load the agent, I'm loading the E2I commands. And if they don't load in time to complete the TTI and actually send the UE data back, then SRSRAM will crash. So performance is an important part. So the solution, if the hard drive was too slow, the solution I came up with was to use a RAM disk or using a file system inside the RAM instead of using the hard drive. And that speeds things up without having to share a variable between the threads. So that was a simple fix, or a relatively simple fix. And I can see if I can find where if I have the command that I did. So I just did something like sudo mount, you can use this thing called tempfs in Linux. I'm going to put this in the documentation later, but you can mount a temporary file system that is inside your RAM. And so I just made one that's like about the size of how much IQ data and commands we need, and I put it in this mount temp directory. So yes.
So will you have this instruction on our website so people can follow? Thank you.
Yes. Yes, because I do want people to follow this later. So, right now I just want to finish off by actually showing the demo off. So, now that the command's here, and you can kind of see that I was running it a little bit ago. Let me see if I can go back to the logs for the Xapp. Connection reset. Okay, so I think we're in a good state to go. I have the EPC already started here. I'm going to start the base station and see where I get it to connect. And it stopped, so I'm going to have to restart the Xapp, and that's not a problem. It won't take too long. Let's see, rollout restart. Then I'll give it a bit. In the meantime, I need to also make sure I have the iPerf server running on the UE side. And then once everything's connected, I can also start a connection on the iPerf. Once the UE is connected, then I can actually start the other side of the iPerf. So in this case, I think I've waited long enough, so I'll start it. I'm getting constant messages. That's good. I'm going to start the UE now. And if I get an IP address, 1604, so I'm going to type that in this command. And now we have a good connection for the UE. So now if I go and click T for trace on the UE side, we can investigate some of the statistics. So we're looking at this is the MCS for the uplink. So when it's a fixed value, it's set to 28, but it sets itself every 8 seconds to a fixed, it should alternate between a fixed and a dynamic MCS. So if I go to the base station side, sometimes we'll see commands like received. Hold on. Actually, I'm going to zoom this one. So we're receiving message M, and M is the signal to enable the dynamic, and Z is to enable a fixed value. So if I go Z, then I should see on the I should see that the MCS is 28. But now if I get a message that says M, then it's dynamic again. So I'll go back and I see that the MCS is reverted to about 2021 or so. And then the iPerf just finished, so I can start it again.
Let me recap. So the model of the Xapp, right? It sends this command, M and Z. It says whether you need an adaptive bit rate or not. Okay, depending upon the interference you see in the environment, right? Because we collected IQ or the spectral runs based on which the model predicts. So that's what we are able to see. But once you see M, then you have, let's say, the 28 MCS. When you see 21, 25, right? You are using adaptive, or that you are using less MCS so that you still have a good decoding of the messages even when they are. That's the.
Yes. So we periodically receive. So we get these E2I commands. The M. So M is dynamic MCS and Z is fixed MCS. And we can see at the very specific points when we're looking at our trace where we have like 21, where it goes to 28, which is the fixed value that we specify. And then once it goes off, then it goes to a dynamic value that keeps changing. I can also look at the Xapp logs and see if I, oopsies. Oh, 1 second. Oh, I actually redeployed it. But if I could take a look at the logs. Then I can see when we're sending a message, like enabling adaptive MCS here and disabling. And what happens is we periodically run the commands. I will receive IQ data and we'll get the buffer. Once we get enough IQ data, that's the size of, we're basically 10 milliseconds of a spectrogram. Then we're processing it, and I can also match this with what we see in the code. If we're looking at this, so we receive the IQ data, we receive the buffer size of whatever we need for the spectrogram, then we process it. So then we can run a prediction on our IQ data. We turn to a spectrogram to make a prediction, and every 8 seconds it should switch between LTE, 5G, and interference. So then when we see that, we continually send these control messages to keep the adaptive MCS on or to turn it into fixed mode by disabling it. So then this loop repeats on the Xapp side, and on the base station side we can also see we receive these E2-like requests to send IQ data, and we send the IQ buffer back in response. And then we also get these commands for M and Z. For those are the commands for the dynamic MCS. So that's that type of thing that you can control with the E2-like Xapp. And we also in the past week got TX gain to work as well. So those are just a few examples of things you could control. But it is important to know when you're developing both E2-like and E2 service model, you do have to implement on the RAN side exactly how you're going to control things. So if there's a way to do it, or anytime you have to, or you decide that you do want to make a change on the RAN side, if it's not part of the standard or something that you can communicate in the existing service model, then you have to come up with some solution to program it in yourself. So that was what I had to do with collecting, for example, the TX RX. This code is commented out, but this is the code that would affect the, oopsies, wouldn't do that. This is a section of code, affects turning on the gain, setting the TX gain, for example. And SRS RAN makes it reasonable, and also switching frequencies, for example. They expose commands in the API that let you adjust TX gain, RX gain, and the frequencies as well for uplink and downlink. So that's just the idea of some of the things that you can do.
Okay, let me add to that. So those who did not attend yesterday, we'll make all these things available in the release 2 of OAIC with the Xapp, the E2-like branch within OAIC. And these are few examples that you could control in the RAN side using Xapp, using the E2 and E2-like interface. Okay? Anything else you want to say?
I think that's it. I don't want to take up too much time, but if there's any questions, then I can answer. Yes.
I do have a quick question about your Docker container. So you were using one based on Miniconda?
Yes, Miniconda.
But that doesn't have any of the PyTorch stuff in it, correct?
No, it doesn't, not by default.
If you did, because I know that you also showed something that had, you were using YOLO, right?
Yes.
Would you use a different base image?
So I actually did use this image. So I did use this image with PyTorch, but I had a slightly different solution because you have a problem if you have to install PyTorch every time you build a Docker image. It would be a bit slow. So the solution that I came up with was that I would, I'll just give an example. So I would have some code like this where I would only copy the requirements txt in the beginning, and then I would run pip install the things in the requirements.txt. And the reason being that everything in PyTorch or all the big libraries would take a long time to install. But then I would also just copy all the rest of the files in the directory after I've done the pip install. So if the requirements do not change in your code, then it'll still load from this last stage in your Docker file. So then that way you only have to just the Docker image, once you've done it one time, you should just be able to copy the files back. Or you should, anytime you make a change in the code, it'll still remember what you did for the installation, and it should just take a few seconds. So yeah. And is that it?
Okay. So I guess let us give a round of applause and then we'll go to
Thank you.